term you used earlier today, motivational science, is a great term. There should be such a field. And I think there really is a set of phenomena that sort of unite with all motivational phenomena. So I think it's been great to listen to talks today, to hear at least examples of what makes a larger landscape in which our own domains of interest are located, and sometimes to hear about really shared themes or issues or questions that are kind of cut across all or some amount of our interests. So that's exciting. And thinking, what could I share with you today that might be of interest, especially since John has so well covered dopamine and even explained caffeine to us. I agree with everything that John says about dopamine. So what can I tell you? I thought maybe I could share with you a few things that I shared with another very broad group about a year ago, which was arranged by Richie Davidson, one of the Dalai Lama get-togethers. This was on craving and well-being. And there were 4 points that I wanted to share with the Dalai Lama's group, and I thought I could maybe share 3 of them with you today, the ones that might be the most interesting, maybe shared interest. The first point is really that desire, there's a sense in which desire and well-being in Dalai Lama's point of view are sort of antithesis of each other. And desire, so it can be a problem for all of us, maybe for addicts especially, but for all of us to some degree. Desire, one reason it can be a special problem for all of us is because there's massive brain systems that basically can create desire sometimes without reasons. That's only the first point. The second point is that the pleasures we desire are different from our desires for those pleasures. They're psychologically different. Usually we desire what we expect to like, but they are psychologically different, the liking and the desiring, and they're neurally different, and this has some implications for well-being too. And the third and last point that I'd like to describe today is a very counterintuitive notion, the one that I'm really most interested in your feedback, because you may have insights that I don't, is that very opposite emotions such as desire and fear, wanting and fear, can share something in common, definitely neurally and perhaps psychologically. And we'll look at that and curious why desire and fear can be in common. But sort of situated for us as psychologists, maybe I should mention that I find the Danny system very relevant to what I want to talk about today. Most of our desires are planful goals, desires, but these mechanisms that I'm going to talk about are really the other category for Danny. Sometimes these mechanisms spill into our conscious desires and give a special added urgency to the things we have conscious goal or desires for. But sometimes they can act in opposition, and that can be especially problematic in cases like addiction, but it can be problematic in smaller degrees for all of us. So it's relevant to the common thing. It's also very relevant, thinking of Columbia University, to the Michelle Marshmallow phenomenon. This kind of desire system I'm going to talk about is very much, it's not a drive, it's not constant, not at all. No, it interacts with things like marshmallows on the table in front of us now. It's a reactivity system. So that's right. But let's give you an example. And there are implications of these for well-being. I want to give you an example of a powerful desire that kind of detaches from reasons, detaches from likings and from reasons for desire. And to sort of pinpoint the sort of brain system, we heard today that intrinsic motivations, Rich shows that intrinsic motivations lit up the striatum. John told us that the dopamine system lights up the striatum. All of us who study sensory pleasure, we've always been studying the striatum. It's almost a surprise, in a sense, that intrinsic motivations, and here's Richie Davidson, this is a study Richie Davidson's group, showing that sustained well-being in older adults is also lighting up the nucleus accumbens or striatum. This to me is a surprise. If you'd asked me 10, 15 years ago, where is happiness an intrinsic reward in the brain, I would have said, well, it's going to be cortical and sensory pleasure or subcortical. Well, that's not the way it is. There's sharing. It kind of taps into a theme of sort of evolutionary co-option that we've heard about earlier today. I think that's what's happening. But it gives an entry point for those of us who've been playing around with sensory pleasures and desires for them. It may be that what's true for sensory pleasures might also be true for other kinds of rewards. And so that might be a reason to be interested in this dissociation. I want to talk about wanting versus liking versus learning. In all of us psychologically, there's kind of conscious pleasures and maybe less conscious hedonic impacts. There's various kinds of learning. There's various kinds of wanting. Plants will go directed ones and more basically salient wanting. But for the purposes of simplification, you can kind of break it down just into liking, wanting, and learning. What I want to do is give you a concrete example now where wanting is intensified by tapping into this large brain system of which dopamine is a central part, but it's much larger than dopamine, which can activate wanting. So here's the example. This one, kind of a recent technique, is going to interact very much the brain dopamine activation or the brain lipid activation with cues and imagery. In this case, it's an animal experiment with a kind of new technique for turning on the brain system, optogenetics. Basically, we're going to turn on, in this case, the amygdala, and we're going to give a rat a happy choice between two nice things, similar to the situation that John showed. Two nice things, a sugar pellet or another sugar pellet. There's only one difference between these two sugar pellets it can earn, and that is this activation of the amygdala is paired with one of the sugars. It's a laser activation that activates the brain system. If you haven't heard much about optogenetics, it's basically just a notion. It turns neurons into eyes, in a sense, and excites them. In our eyes, we have photoreceptors at the back of our eyes. You can put photoreceptors in neurons. You can persuade them to sprout their own photoreceptors. If you inject a virus into the brain around the neurons, the virus doesn't spread far, it just sits on the neurons where you put it. The virus gives the gene for the photoreceptor into the neuron. The neuron takes up the photoreceptor gene, and it begins to make photoreceptors and sprout the photoreceptors. Now the neuron has eyes, and if you shine light on it, the neuron fires with this particular sort of space. So this is what happens. So you inject the virus into the amygdala as the gene, wait a few weeks for the neurons to make their photoreceptors, and then shine this light, and now you'll see an example of what's going to happen. So let's see it. Here's the rat that has its choice. You're going to see first it can work on the laser lever, and it'll get the sugar pellet in the middle. Then it'll work on the sugar-only lever, and it'll get the sugar pellet. And then it'll get a choice. It's the choice that's special and interesting. This is done by Mike Robinson, a former postdoc. So here's the laser lever. He's pressed on it. He's got the laser and he's doing the sugar pellet there. He's very quick and eager to do that. The laser lasts for 8 seconds. Now we'll get this other laser. It'll be this other lever, which has no laser. It's the sugar-only lever. So he's very eager, nibbling on the lever, interested in that lever. It's got the sugar pellet from right there in the middle. Seems interested in both equally. But what happens when the choice is available? Goes to the laser lever, stays on gets the sugar, goes back to the laser lever, or stays on the laser sugar lever. And is ignoring the other lever, stays on that laser sugar lever, gets the sugar pellet, goes back to the laser sugar lever. It seems almost like an addictive focus on this. The rat can earn more sugar pellets if it alternates, but it's costing itself sugar pellets by staying so fixated. But it's just absolutely fixated. This last one we'll see is the sugar pellet. Looks at the other one, laser lever, goes back. So this is such a focus. The question is why psychologically? Why is this happening psychologically? And one possibility is that the laser is making this rat want this lever so intensely, this particular sugar, because it's making it like that particular sugar content. That's a possibility. We can ask the rat about that possibility. A way to ask would be to use a kind of technique that David Steiner developed decades ago in Israel for human infants, giving them nice tastes or nasty tastes, and Harvey Grill adapted it for rats. I've used it, John has used it, and Peter Allison has used it. So it's basically the same way human parents have asked their infants if they like sweetness. So let's see a little movie. This is David Steiner. This baby just got a sweet taste. This is its first day of life. Let's go back and see that again. Okay. First day of life, sugar, sort of relaxed tongue protrusions. Now the rat's from underneath getting sugar infused into its mouth. Painlessly through the whole hand. And when we see the tongue protrusions, we slow it down. Tongue protrusions, then we sort of licking the lips to the sugar. Bitterness. A little bit different. It keeps your scritching of the nose and brow. The rats can't scritch the nose and brow, but the rat can gape. It can shake its head, flail its nose, and such. So bitter versus sweet. Hungers will accentuate the positive. Learned preferences and aversions can shift tastes. Brain manipulations can shift these reactions if it changes the pleasure of the taste. Does the laser change the pleasure of the taste? Well, the answer is no. This is sugar solution to the rat. When it has no laser, this is sugar solution. When it does have the laser turned on, these are its positive ionic reactions. There's really no sugar. The laser doesn't make the rat want this sugar more because it likes the sugar more. But perhaps the rat likes the laser. Perhaps it wants and likes the laser. We can ask the rat by letting itself stimulate, press a lever to burn the laser. It won't. It won't do this for the central amygdala. Even if we ask a very simple test like the original pleasure electrode test of Jim Olds. When Jim Olds appeared to discover pleasure electrodes, they didn't yet have the Skinner box. They just put them in on the table. When it went to a particular corner, they gave the stimulation and it stayed in that corner. That's how we discovered it. So we could do that with a rat. We could put them in a chamber where it could go round and around the outer rim, and the percentage you see is the time spent in the laser corner, 26%. It's basically a chance. He doesn't care. When I showed this to the Dalai Lama, he stopped and he turned to his translator and he went on to Tibetan for about 30 seconds. And the translator said, His Holiness is not convinced that the rat doesn't find the laser painful. Excellent point. Excellent point. Maybe it's an aversive drive that the rat's trying to escape by pursuing the sugar. But this test, the reason I show this test is because, again, it asks that question too. We can ask the rat, does it want to avoid the laser? It doesn't want to avoid the laser. If you're realistic, you can easily avoid the laser by just staying out of that corner. The others. It doesn't care. It wanders through. So it's an interesting psychological case because you see it doesn't seem to care about the laser by itself. It's not transforming to sugar per se, yet you get this intense preference that you saw on this laser pair left. It's psychologically interesting. It works for other things too. You compare the laser with cocaine over another cocaine and it makes it go. But the rat doesn't care. It prefers the cocaine that's associated with them. But the rat doesn't care about the laser by itself. So it's as though it's transforming the percept, the representation of some things in the world that have value to begin with. They can be tremendously amplified in a addictive-like fashion in this kind of desire. That doesn't really have a reason in the usual sense. It's not a bowl of sugar, it's not a laser, it's not the this kind of has implications because this same event, we think, is produced by activations of the mesolimbic system. By going in the amygdala, we can focus it specifically on this rather than that. We turn on the dopamine system so that everything can become more valuable in a sense and in the ways that John described. But in addiction, drugs and abuse don't just activate dopamine systems, as my colleague Terry Robinson has argued for years. They also permanently sensitize them in the sense of making them hyper-reactive, in the sense that a person who is sensitized when they take a dose of drug that releases dopamine, the sensitized person releases more dopamine to the same drug than they would if they were not sensitized. It's a sort of permanent change that can happen in these systems. It can happen in parallel with tolerance and withdrawal, but the tolerance and withdrawal goes away if you stop taking the drug. The sensitization doesn't go away, it's more permanent. For years at least, maybe a lifetime. And it's caused by many different kinds of drugs abuse. But it's not this diagram of the wanting versus liking that's meant to capture this desire of taking a life of its own. But this is a bad graph in a sense because it's misleading. It's not a constant desire that's always up there. That's not the way it is. It's a reactive system. If we switch dopamine in the nucleus accumbens, we can't tell often in many behavioral tests if there are no cues to react to. The rat doesn't show us. Even if we're recording from downstream brain structure, we can't tell what they're showing in the nucleus accumbens until we get the reward cue, and then there's this massive momentary burst of activity, of desire, and neural activity. It's a reactive system. It's the marshmallow kind of effect. So it's triggered by cues, and people it's triggered by imagery also of the rewards. The last thing to say about it is that even to say it's hyperreactive is a little bit misleading because it's not equally hyperreactive at all moments. Things like the laser on board will increase its reactivity. Things like taking a drink will increase its reactivity. Things like emotional stress and various emotional states will increase its reactivity in this moment. So an addict might be sensitized and successfully give up drugs and successfully resist cues time and time again. Yet in a certain moment, in a certain state of stress or otherwise heightened reactivity, we have the same cue and well. So it's a kind of challenge, and it's psychologically interesting. That's the nature, I think, of this kind of design. But pleasures exist. Desire can decouple from pleasures, and that's really the point. But pleasures do exist, and they do have their own mechanisms. And here, just in a nutshell, even we can turn on pleasures. As John said, the nucleus accumbens is not a pleasure center, and dopamine never generates it. But the nucleus accumbens contains a little pleasure center. It's only like 1/10, 10% of the nucleus accumbens. Dopamine will never act there, but other things can, like natural opioid neurotransmitters or natural marijuana neurotransmitters. The island here, this hedonic hotspot, is not alone. There's several others in the front of the brain, the prefrontal cortex, the insula, and the orbitofrontal cortex. There's one down deep in the ventral pallidum that the accumbens talks to. There's one in the brainstem. They're all sort of interconnected functionally, these various hotspots. They all have the ability of possessing a unique capacity of creating intense pleasures, or at least amplifying intense pleasures, like to sweetness. This here is a blow-up of the nucleus accumbens, sort of sideways blow-up of the brain right here. So this would be what's called the medial shell of nucleus accumbens. It looks a little bit like a neuroimaging map, but it's not. It's really a causation map. It's not a neural coding or a neural imaging lining up map. It's a causation map. Each splotch here is a little microinjection to show you how this hotspot is defined. Each little splotch is a microinjection. Wherever it's green, it's creating intense desire. This is an opioid microinjection that stimulates opioid receptors. It makes the rat, wherever it's green, eat twice as much as normal, or 4 times as much as normal, or even 8 times as much as normal. So this is an intense desire. The green goes underneath the orange too. So the entire goes out, the entire piece of numbers is green. But only this little splotch here is also orange and red, where it's not only making the rat want the food more in the sense of eating it and working for it more, it also is making it like the taste more in the sense of those reactions. It's developing a trigger for those hedonic reactions. That's a hedonic hotspot. And as I say, it's not quite alone. There's several of them. What they share in common in these hotspots, where you can amplify liking, is they kind of work together. You turn one on and it recruits the others to create the intensified sensory pleasure. They all come on together. If you were to interrupt that recruitment, you'd stop the pleasure. They're very fragile, this system. It needs to recruit the whole system. So it's anatomically tiny. It's neurochemically restricted, never dopamine, but just a couple. And it's functionally fragile. It's very easy to interrupt. So this may be a reason why intense pleasures are relatively rare in our life compared to intense desires. The system is just enormously fragile compared to the robust system of desires. Very last point, 5 minutes. So very last point, 5 minutes. So here's the counterintuitive thing. That opposite emotions share the same brain systems, and it's of interest to us as psychologists. We all may have the notion that things like amygdala are for fear and accumbens are for rewards, intrinsic and otherwise, and that's certainly true in a sense, but not entirely true, right? Because the laser example, that was actually amygdala, that wasn't fear, that was intense desire from amygdala, and we can get fear out of the nucleus accumbens. Maybe not a this freezing passive fear, maybe more a fast kind of paranoia, active coping, reaching out approach kind of fear. So again, let's blow up the nucleus accumbens, and the last experiments are to get, again, painless microinjections. These are basically strong signals that are interfering with cortical glutamic signals to the accumbens. We don't have to worry about the details. If we do these little drug microinjections, what happens is we get strong desire, again, out of the nucleus accumbens wherever it's green. But wherever it's red, the same microinjections are, these microinjections are producing fear of the rat. Our rats are normally very tame. We bring them into the lab, we give them treats, controlling experiments, it's a reward lab, we want them to feel comfortable. They don't bite us. But after a red injection, you cannot touch them. They'll screech if you touch them, they will jump right out, they'll bite you, and even if you don't do anything, if you leave them alone, they'll do to us what rats and ground squirrels in the wild will do to predators and such, a sort of defensive burying, kicking of sand in towards the direction of us in the room. So an active, fearful response. And in the middle, they'll do both. The same rat with the same microinjection has both desire-like appetitive behaviors and fearful ones in the same hour after the microinjection. But what's most interesting is that The same brain site can flip back and forth. And this is the very last thing. It's the same microinjections. It's just done in 3 different situations. This is really a Shacker and Singer kind of thing. Same brain microinjections, either in the regular lab like before, or in the rat's own home rooms that are, dark. You don't hear sounds except the fans. It smells like rats. We wouldn't want to spend time there perhaps, but the rats seem to prefer it. Or a world in which we're sort of aversively Imagine that very loud. It gets annoying to me after a minute or so. Rats also find it annoying. We'll turn them off. They can turn the off. It was universal efficiency. By going here, they turn them off. By going there, they turn them off. They learned to turn them off. In the first 15 minutes, they turned them off, and by the end of the hour, it seems way off. They prefer the dark rat home rooms over the lab, so they prefer rat over lab, not over Iggy. But what if they can't choose? What if they just get a microinjection, and for 30 minutes they're either home or in the regular lab or in Iggy? This is what happens. Regular lab, you see the desired red gradient just like before. At home, the desired part expands and eats up everything except the very back of the nucleus accumbens. And under Iggy, the red expands, big fearful reaction, the yellow expands at both fear and desire, and you just get a front anterior rim of pure desire left. So some spots are flipping entirely from red to green as you go back and forth. The same rat, same drug microinjection, same brain event, honestly. That means something. I don't know what it means. But come to it. So to end, I'll just say this is what we left with the Dalai Lama, the notion that these sort of desire systems, this deep brain wanting system, can give these intense wanting, grasping qualities to desires, especially when you encounter the right marshmallows, and especially when you're in the right state, being 2 years old, but also being sort of negatively activated at this moment. It turns out individuals differ in their regard to that. From Dalai Lama, it was important to emphasize that this wanting system can be activated without distress or need. Desire is partly, in their framework, I think, an attempt to escape from suffering, is desire for other things. But you don't need suffering to have desire. If you cure the suffering, you may not eliminate desire. That's the lesson. And you can have wanting also without pleasure, either liking in the moment, and even expectations of liking. For us as psychologists, this is the final, which is like, I would take it, well, pleasure liking exists, and it's fragile. How it relates to well-being, well, that Richie Davidson's slide that left up the ventral striatum accumbens, just like intrinsic rewards, there's something about that that can contribute to well-being. This is correlated with well-being in the Davidson and the adult studies. Wanting is separate, it's very robust. Maybe it can add zest to life, that's my personal view. The Buddhist view would be maybe not, but certainly all agree that it's dangerous and excessive. And somehow desire can flip into fear. There's something